chief scientist, who is going to be explaining and sharing with us some of the current and future scaling solutions that the team has been working along with the rest of the community. Go ahead, Sergio.
Thank you.
Okay, hello everyone. Thanks for coming. Okay, so next slide, please. Okay, so when I joined IOVLabs, I wanted to RSK to really be the platform for financial inclusion. And IOVLabs motivation is that we want to improve the life of 1.1 billion people who are excluded from the financial system. And our tools are, of course, RSK, but also smartphones, Bitcoin, second layer payment systems, and stable coins. And this is the toolbox that we are going to use to scale RSK to 1 billion users. Next. But as you know, and I'm just going to repeat probably things that you know very well, scaling decentralized systems is not the same as scaling centralized ledgers. Like centralized ledger, you just vertically add more hardware, or horizontally you add more computers. So you create clusters of computers, and what this means in the decentralized world is that you need to consume more resources from each node, each full node of network, and that goes against decentralization. So if people start, if the resources are too high, people start delegating their full nodes, and then we lose all the decentralization, which is so important for us. And then there is this concept of sharding that has been mentioned in the last years, essentially in the Ethereum community. And I think, and many other people think, that it has many problems. The main problem is the loss of DeFi composability. Like if I have an application running on a shard and there is another financial application running on another shard, then these two applications cannot directly communicate. And then we have the data availability problems, so that if there's many shards, where this data is going to be stored? It's going to be stored by a subset of the nodes. So this push the network to a what I call two-tier networks. So networks where the full node is split between different roles, which have their own challenges. So next slide, please. Okay, so as we know, scalability in layer one, it's a trade-off, okay? So if we want, layer one privacy and anonymity, then we are going to consume a lot more resources from the full nodes than if you are going to do single transparent account per user. Or if you want full programmability and composability of applications, then of course we are going to need a lot more resources than payments only. So this is known that there are trade-offs, but we can make the right trade-off. The important thing is that by focus on the design, we can choose the trade-off that we are going to make while keeping decentralization as a guidance in all our decisions. Next, please. Okay, so this is a diagram of how some of the known blockchains are positioned in terms of scalability. So in the x-axis, I have the amount of resources consumed in a full node, and in the vertical axis, I have in a logarithmic scale the transaction per second that these blockchains allow. Of course, the blockchains that consume lower amount of resources and also achieve lower transactions per second are Bitcoin and Zcash. And then we have a distinction that I want to make about the difference between two-tier networks and single-tier networks that I talked before. Two-tier networks are networks that they split the role of a full node into nodes that, for instance, store data and nodes that consume data, or nodes that produce computation proofs for transactions and nodes that only verify those proofs. So two-tier networks like Mina or probably Ethereum 2.0, we really don't know, but probably it's going to be a two-tier network, are more like a single-tier network composed with a rollup. So if we want to be fair in this comparison, we have to compare these two-tier networks to the composition of a single-tier network and a rollup. So I'm going to just leave out two-tier networks now and focus on single-tier networks. So all these EVM-based or EVM-compatible single-tier network, they are all essentially together in the same group, right? They provide between 10 and 50 transactions per second. The ones that wants to provide more, let's say the Binance smart contract chain, what they do is they are just simply increasing the block gas limit, right? For instance, the Binance chain has a 25 million block gas limit, and that is not scaling. They are probably past this red line of losing the decentralization properties. Okay, so what we have to do is focus on keeping layer one decentralized and combine layer one with second layer solution. Next, please. Okay, so to learn a little bit about this second layer solution, I'm just going to see what is achieving 1 billion, serving 1 billion people means. So the use cases for blockchains and for financial inclusion goes from interbank settlements to wire transfer to retail payments to micro and nano payments. So there is a lot of use cases. Next step, please. So what the traditional financial system, what it does, it split these use cases between different systems and different security models and different transaction costs. So for instance, interbank settlement, of course, is not the same system that you do with credit cards. Probably it requires a lot more security, but it's a lot more expensive. Okay, so most in-app purchases or shopping is done by credit cards with a lower cost, but also a higher risk. Okay, so this is a higher risk of fraud. Next one, please. So we can do the same with blockchain networks. We can also optimize different layers and build a stack of layers to achieve the true financial inclusion to reach 1 billion users. So when I say that reach 1 billion users, I'm talking about active users. And for this, I'm talking about users that perform at least 5 payments a day. So Bitcoin and Ethereum and RSK, without any second layer solution, they can only serve about 100,000 users, active users. Up to that point, the block is full and transaction prices will go up, and then we won't be able to do financial inclusion with these networks. If we combine Bitcoin with the Lightning Network or RSK with the Lumino payment channel network or Ethereum with the Raiden network, we will probably be able to reach between 3 million and 15 million users, active users. But the huge problem with payment channel networks is that this technology is not very suitable for financial inclusion, because the unbanked user is a user that does not have capital, nor there is a counterparty that would trust these users to pre-deposit an amount of coins to create a payment channel. So essentially, these payment channel networks do not work well for financial inclusion. So what do we do? Well, this is why second layer solutions like rollups have been invented. So if we combine RSK with a rollup or Ethereum with a rollup, we can reach about 160 million users. So that's a lot, right? This is about 2,000 transactions per second of volume. But still, this is not enough, okay? We want to reach this billion users. So what do? Well, the only solution is to increase the capacity of the on-chain layer, okay? And can we do this? Yes. And in the case of RSK, for the last 3 years, there have been many proposals to increase this capacity while keeping RSK fully decentralized. So next, please. So essentially, the stack, the RSK stack, to serve these billion users would be something like this. Like interbank settlements will be done over Bitcoin, okay? So probably transaction will cost $50, $100. It just doesn't matter. B2B payments will occur on-chain on RSK, but all shopping, normal user payments will occur over a rollup. And the micropayments and nanopayments layer will be served by the Lumino off-chain, Lumino or a similar payment channel network technology. And then new use cases like streaming, advertising, online content, networking, paying for networking, all these micropayment channels will be performed over Lumino, for instance. Next, please. So what are these second layer scaling systems? Well, you probably already know about them, but just to introduce them, these are like second layer blockchains where each one of the second layer blockchains blocks are committed into the layer one RSK. So an RSK block can have one or several commitments of second layer blocks from this virtual blockchain that is being created. Next. So there are many different solutions for second layer payments and can be categorized in different ways. I like this diagram that classifies second layer scalability solution in terms of where computation happens, so where transactions are verified and where transactions are stored. So in the vertical axis, we have where transactions are verified. And so the optimistic rollups are those that there's a subset of nodes that verify transactions, and the most full RSK full nodes do not verify these transactions. So they need fraud proofs to penalize misbehavior on this subset of nodes. And on the bottom side, we have zero knowledge rollups where each one of these virtual blocks that is committed to the RSK blockchain, comes with a proof of validity proof that the state transition is correct. So these are much more secure. In the x-axis, we have the solutions that commit all the transaction data on chain, and in the left side, we have those that do not. That they have this is a two-tier network where some nodes will store the data, and so new nodes will need to query these nodes to get transaction data. I'm particularly very much inclined for solutions that are zero knowledge and with on-chain transaction data, such as ZK Sync. So from IOVLabs, we are working on porting ZK Sync and improving ZK Sync to be very efficient on RSK. Next, please. So another interesting way to analyze second layer solution is in terms of what functionality they provide. So in the top, we have the blockchains that provide full EVM compatibility. And in the bottom are the ones that only provide payments. Of course, we wish to have full EVM compatibility, but the most interesting solution, the most secure solutions, which are the ones that are zero knowledge, they don't directly implement the EVM, but they implement their own programming languages, which are specifically made to be very efficiency, to prove programs correctness very efficiently. And for instance, in the case of ZK Sync, they have created a transpiler from EVM to these new languages. And this is the vertical axis. And the horizontal axis, we have privacy. So in the right, we have solutions that are fully transparent, and in the left, we have solutions that are private. Of course, we would like to have privacy right away, but the problematic thing is that the two solutions that provide full privacy, they have adopted the Polaris license, which is a very restrictive license. But we are in talks with them to bring these solutions to RSK. Next, please. Okay, this is a bit, I don't know why the font is small, but what I wanted the message I want to transfer here is that all of these rollup solutions, they don't have fixed cost. All the rollup costs are related to the on-chain cost. For instance, the cost of a rollup transaction could be 1/20th of the cost of an on-chain transaction, but there is always a proportional relation because rollups need the transaction information, even compressed, to be posted on chain. So there is the only way that we can scale to 1 billion users is by increasing the on-chain capacity and keeping the on-chain cost low. Next, please. Next. So RSK community, and in particular the IOV research labs, have done a lot of things in the past 3 years to achieve this scaling of the base layer. I think I have very little time, but I'm just going to mention some of these proposals that came during the years together with code. And these proposals are just waiting for the right moment to be taken by the community, merged into the full node, and put into production. So we just need consensus that these are the right tools to achieve this billion user scalability. So for instance, we've been working very hard in storage rent. There were 6 proposals for storage rent for RSK, and the last one, I think that is the best one. It's going to come up in this month probably. And what allows storage rent is to reduce the I/O requirements of a full node to process transactions. So then we can process a lot more transactions per second. In case, for instance, of blockchain storage, there is a proposal, RSK IP 2014, to prune rollup data after a certain amount of time. And this is something that the on-chain layer will allow second layer solutions to prune their on-chain data after a year, so that we can make sure that every user has downloaded this data, but this data do not stay in the blockchain forever. Then we have a proposal for pruning all blocks in consensus, which is called ephemeral blockchain. We have a proposal for paying full nodes, to incentivize full nodes from transaction fees, so that they can have more incentive to run full nodes. There is a proposal for signature aggregation to reduce the size of transactions. There is a proposal to create transaction templates and signature chaining, which also reduces the size of transactions. There is a proposal to compress the Bloom filter data so that past blocks do not need to store Bloom filter data forever. Next slide, please. So regarding execution, there were 3 proposals to do parallel transaction execution. And one of them is very efficient because it was made taking into account the RSK unitary structure. So this is another interesting proposal that could be merged very soon. Then we have proposals to reduce the bandwidth consumption. For instance, there is a proposal to compress blocks based on tri-chain sets. And then we have something that, for instance, for the Nakamura consensus change, which we developed during the last year, but we have not published, and we will publish this year, is a change in consensus, a proposal to change consensus to RSK to reduce the amount of information that is required to handle all block ankles. And if we really want to scale, if we really want to create RSK sidechains, the past year we created the sync chain proposal, and there is a paper about this, and we created the universal merge mining system so that we will be able to create proof of work based sidechains to RSK. This is of course the most promising, but sidechains they have this composability problem. So this is another way of doing second layer scalability, but it's more about different use cases, like a use case per sidechain. Next. So with these new techniques, we could, if we assume that each node consumes the same amount of resources, then Bitcoin can do 5 TPS approximately, RSK and Ethereum could do 25 TPS. And if we implement all these changes into RSK, we could achieve 150 TPS consuming the same amount of resources. So this is very promising. And I hope that we implement these techniques in the right moment so we don't hit any bottlenecks. So next, please. So yeah, as a summary, RSK can serve 1 billion users with the help of these second layer scaling solutions. This one layer and second layer creates a combo that basically transforms our network in a 2-tier network. But we also need to optimize the on-chain layer so that we can help these second layer solutions be more efficient. And last, we need to coordinate between second layer scaling developments, the onboarding of new users, and these changes to the on-chain layer, so that we never price out users in the path to financial inclusion. So we never hit a technical bottleneck during this, this trip from the point we are now to serving 1 billion users. So there is a lot of coordination needed in the community. We will need consensus from the community to move forward with these proposals in the next years. So yeah, that's it. I think I've taken a lot of time. If there's, I don't know if there's time for questions, but thank you.
Thank you so much, Sergio. I think you put it super clear how important scalability is for the RSK ecosystem, and not for a random reason. It's because we believe that RSK can take Bitcoin to its full adoption and serve billions of users in order to be able to be so inexpensive for those users to be able to use the network. We need to scale. So thank you so much for your presentation. It's amazing. I think you're going to receive a lot of questions to your email.